Hi there everybody, my name is Kyle and I also go by Sterling online. I'm an avid video game enjoyer and have been so for almost 3 decades now. While I may not be a professional developer, I think it's fair to say that I've at least been around the block on the consumer side of the spectrum, and I have previously dabbled in game design and production through RPG Maker, Garry's Mod, Unity, and now due to its exceptional accessibility, I've moved over to Godot. Outside of the world of video games, I've also got some web design experience as well, but again, I must stress, I have no formal education in software development or engineering. These videos are also not intended to be viewed as instructional, but instead are intended to be viewed as a retrospective in progress. I've always regarded video games to be the premier media format, the best parts of movies, music, and books, all rolled into an interactive medium. And I'm most at home in genres ending in RPG with a particular fondness for Bethesda and Blizzard games that blossomed into a love for environmental storytelling and design. I've also lost countless hours to the early 2000s Eastern MMO wave, but I've dipped my toe in many a genre.
I'm something of a scientist myself.
I've owned at least one console from every major player, my favorites having been the GameCube and DS, but I truthfully hold no allegiances beyond my undying love for Steam. Some of my favorite games include the Diablo, Borderlands, Animal Crossing, and Battlefield series, and I enjoy a good game of Commander on Tabletop Simulator. I've always felt that producing and designing a multiplayer game would be a pinnacle achievement, a crowning jewel. I've made tons of small proof-of-concept style minigames, and sure, combining everything into a little single-player adventure would certainly also be an accomplishment. The near insurmountable challenge that is solo developing a multiplayer game has a genuine allure to it, and it's a path ventured by many foolhardy, bright-eyed developer. It's also a path littered with dehydrated and sleep-deprived developer corpses, so heed my warning. Should you decide to venture along this path as more than a mere viewer, you should know that you will almost certainly never even get close to where you would like to. That fact alone, however, should not deter you, as it will make the victory all that much sweeter. Share in the spoils of my failures and allow the torch of my despair to guide your path forward. Before we even write a single line of code, it behooves us to set up some version control and backup systems so that we never lose too much progress should something catastrophic happen. I've already done this, but if you're unfamiliar, there are a ton of great resources out there, so I will only briefly skim the surface here for what you'll need to know for context. GitHub is a web-based platform for hosting and collaborating on Git repositories. Git is a free and open source, or FOSS, distributed version control system that tracks changes to files, supports branches and merging, and helps enable decentralized workflows. GitHub Desktop is a graphical Git client that simplifies the process of managing local repositories and syncing them with GitHub remotely. These two utilities are exceptionally strong, lightweight, and easy to set up, one of which you don't really even interact with. After you register your account on GitHub, you can download the desktop client. Next, when you open GitHub Desktop, the Systems menu at the top allows you to create a new Git repository with some additional options beyond naming the repository and giving it a description. It's important to take note of where you point this repository to, as you'll need to create your Godot project folder in the same location. For me, this file path was on an external hard drive at GitHub. Once created, you'll need to publish the repository itself to the GitHub servers with the click of a button, and then you can even see this change reflected online by going to the GitHub website, logging in, and clicking your display icon at the top right, selecting repositories, and then clicking into the repository you just created. Now you've basically created a folder on your computer that will track its changes with a historical record, and you can push that folder and its record to an online source. You may want more backups in the future, but this should suffice for prototyping. Next, head on over to the Godot website and download then install the developer's tools. If you have a Steam account, you can download it through the Steam Marketplace for free as well. Godot is an object-oriented game engine built in C++. It natively supports its own scripting language, GDScript, but it does have official support for other languages. I won't be developing in those, so they won't be discussed. GDScript is a Python-inspired language that trades performance for accessibility, but that should not be heard as GDScript is weaker than other languages, and instead should be heard as, if you are interested in hyper-optimization, you may be more interested in utilizing one of the officially supported languages instead. I'd also like to quickly point out that I just called Godot an object-oriented game engine, and this is my understanding of it as it's primarily designed around nodes and trees. As a result, If you are interested in following an entity component system to its strictest definition, then you may also seek to leverage a different engine, as you would effectively need to do away with the majority of what's already been built in Godot for your ease of development. If you are a bit more flexible in definition, you certainly should be able to achieve similar functionality to an ECS. It just makes more sense to leverage the engine than fight against it. Once Godot is installed, launch the program and create a new project folder. Ensure the project path is set to the previously indicated file path and set the renderer appropriately based on the style of project you intend to create. I usually choose compatibility so that the games can be played on the greatest number of devices. Ta-da! Now your Godot projects exist within your Git repository. That means when you save your progress at the end of the night, you can also push your changes to an online backup. We're not quite ready to code, eager beaver. Take that keyboard out of your mouth. There are a few handy settings and boilerplates I like to start with when embarking on this style of project. Firstly, as Godot is primarily type inferred, I go to Project Settings, General, Debug, GD Script, and set Untyped Declaration from Ignore to Error. And then I make sure that we are exporting two software contexts, a server and a client. These are easily set in the Project Export section by ensuring that your export path is filled appropriately and your server export has the option Export Console Wrapper set to Debug and Release, as well as its resources export mode set to Export as Dedicated Server. This strips the server of unnecessary visual or auditory data to keep it lean, as well as sets a dedicated server flag that we can leverage primarily for initialization. Then, you'll need some form of documentation, as bloating your codebase with it is generally inadvisable. You should, however, make use of the powerful doc strings we're allowed to create by preceding functions, classes, variables, with two hash marks followed by the description. This creates a hover-activated tooltip. This is the easiest way to further empower your self-describing code with more contextual information, guidance for use, and other important details. Another powerful tool would be a general photo editing or like software with layer composition. You can use this to track intended initialization order, which systems should be speaking to which, your basic level design and gameplay loops, and just about anything else you might need to remember for the future. As your game grows, having good organization and documentation truly does go a long way, so build good habits early.
Godot, there you are! Hey, what are you doing lying in all this... Hey! Who made this big mess? I did? You're sure it's not...
Sales team.
What? Okay, I made the mess, which means I have to clean it up. So get ready for the
Worst time of your life.
This also means you'll want to decide on general folder structure early, especially if you're one to use a lot of magic strings and numbers. Magic here is just a play on abracadabra or open sesame, where you must know the magic phrase. Godot has a relatively robust code completion feature, so magic numbers and strings should generally be avoided so you never accidentally mismatch expectations. At the very least, these styles of variables should be concentrated to specific locations for ease of access. I've narrowed down this specific folder structure for this project. We keep it thin at the top level to help reinforce focus and intent. Our core folder contains anything critical to the application itself, such as booting, networking, or scene flow. The shared folder contains our gameplay logic, as our game must be able to simulate appropriately without a network connection, as even local hosted headless server connections then fail. The entities folder is where the definitions of our complex objects live, and our assets folder will store reusable art assets if they either are unrelated to or would otherwise exist across several entities. I've also created a mental model to aid in guiding design by working through 4 layers of isolation. The engine layer exists independent from any code we write. This is all the lowest level API calls made directly to the Godot engine. AddChild, QFree, isServer are all examples of functions that exist at this layer since they're built into the game engine itself. The gateway layer is the lowest level API we are entirely responsible for as designers and developers. This layer is exclusively responsible for bidirectional communication between the engine and the rest of our software. This layer translates engine events into domain signals, and domain signaled intentions into engine operations, and is an attempt to make long-term debugging easier by concentrating direct engine calls. Networking, registries, save systems, and scene flow are systems we'll find here. The domain layer is where each respective gameplay concept exists, and it contains no Godot engine API calls. This means it should have no knowledge of scenes, nodes, or rendering, and it should be dedicated to data simulation. If you have match or session context, a turn order system, battle manager or loot generator, systems like that are responsible for the active ephemeral game states simulation exist here. Finally, we have the presentation layer, and this is the layer dedicated to reflecting the state of the domain layer. In effect, when you play any video game, and more so when you are playing video games like MMORPGs where session data in context to a character could span several real-life decades, your game can more accurately be thought of as being played within a database and spreadsheets, and your client's just reflecting the state of them and communicating requests. For other fast-paced genres, what you see on your client is generally prediction-forward and reconciliation-based. To put it bluntly, games need to communicate a lot of data, and because of the way the internet works and the way data gets passed around it, there's generally no guarantee the amount of time it takes to get any packet of data from the server to any given client. TCP connections solve this issue of packet order, but come with greater networking overhead. Games that value exceptionally high levels of responsiveness will give their client some level of authority over their input and state reflection, but are still not involved in the calculation of critical events. This is the reason why in virtually every FPS game you'll find moments where you definitely shot first, but still wound up on the wrong end of a smoking barrel. In instances of extreme delays, we can even reevaluate and adjust the relevant data in real time and force clients and stale states back into coherency. You'll be most familiar with this phenomenon as rubber banding, which is a direct result of reconciliation, as you quite literally... And that brings us to the final topic of the video. What even are we designing? I made it obvious that the project is a multiplayer title, but we'll be looking at creating a hybrid RPG board party game with influences drawn from games like Talisman, Mario Party, Dokapon Kingdom, and shows like MXC or American Gladiator, where players compete for supremacy in a zany thematic world. While not a truly massive multiplayer online experience, this genre should give us ample opportunity to explore building a resilient lobby system with peer-to-peer connections, and then we can experiment with multi-threading and integrating platforms like Steam or other technologies like web and database servers, WebSockets, and more. Once we've got a working scalable environment, we can consider removing boundaries and limits with a truly massive experience in another title. I plan on streaming a lot of the process itself, and you can generally catch me streaming Mondays and Tuesdays here on YouTube, but I'll sprinkle devlogs like this here and there to provide updates along the way. The next one likely will be when we finished a rough lobby demo that's joinable with some of the basic gameplay functionality also implemented. So until then, thank you for listening to my ramblings, and I hope you took something useful away from our chat. Don't feel bad if you miss the streams, I'm leaving all the VODs up unedited, so take it at your own pace. Take care.